Everyone, welcome. I am the Electrical Code Coach. I'm super excited about today's video. We're recording from the new studio. You may notice a little bit of echo, but we're building it out, laying some carpet, and the echo will reduce as we increase. We're wanting to expand our audio quality, our video quality, to just serve you better. If you don't know me, I'm the Electrical Code Coach, and I've dedicated my life to help you become everything that you can be in life and in the electrical industry. Today, we're going to be talking about nuisance tripping with AFCI breakers. This also can be included in ground fault and dual function breakers. So if you don't know what an AFCI breaker is it monitors the sine wave. So a good sine wave looks like this. Well, an arc sine wave will start looking like this, and it'll be a jagged sine wave. So this breaker literally monitors the sine wave, and if it starts acting like it's arcing, it will shut off instead of burning the home down or causing problems or damaging equipment. But sometimes this technology, like any technology, can be flawed, and it can be, some of the issues can be from the installer. So let's talk about it now. So a nuisance trip is when it trips randomly, or you can't pin it to a specific thing. Oftentimes, like we're getting ready to learn, you can pin AFCI troubles to a specific thing, and sorry, it's mostly to do with who wired it. Now, the old AFCIs we'll call 08 old. Now, if you don't know, AFCI protection was introduced into the NEC in 1999, and then, it got deeper in 02, 05, 08, and now it's pretty much the entire residential home basically is required to be AFCI protected with a few exceptions. AFCI protection is one of the greatest protections that's come out, but when it first was really getting strong in 08, the breakers did trip a lot. I don't know if it was poor manufacturing or if they were just working out the threshold kinks and things like that, but now with the breakers that we have today, if it's tripping, it's likely your fault or something that the customer has plugged into it. So with that being said, let's talk about nuisance tripping first. So nuisance tripping is tripping when randomly. It's tripping when we don't understand what's going on. We can't pin it to a piece of equipment. We can't tie it to, some event happening. And the worst type of nuisance tripping is when it's tripping at night. When it's tripping at nighttime and the customer, just says, we wake up with a tripped breaker every day, and you're like, oh, what are we going to do? All right, so the first thing that we're going to want to do is work through some of the troubleshooting procedures that we're getting ready to talk about. Let's talk about some common causes of just tripping in general. And any one of these can be tied to nuisance tripping, but oftentimes it is a twilight zone situation, and sometimes you have to replace the breaker and the problem goes away. Let's talk about some common causes for AFCI troubleshooting the breakers tripping. One of them is reverse polarity. Now, some AFCI breakers will work with reverse polarity, but some of them it will cause it to trip when the load gets on it. So you've wired it incorrectly on the breaker side, and what that is going to do is going to reverse the paths, and it's going to cause the AFCI breaker to trip. Now, it may only trip when it has a load on it, or it may trip instantly. Another way that you can really mess this up and cause an AFCI breaker to trip is to get reverse polarity on your receptacle itself. So you are you install the breaker correctly, you go to hook up your switches and receptacles. When you go to install your receptacle, you reverse the polarity, and when it turns on, the paths are crossed, or they're, going back on the, the hot is going back on the return path, and the return path is coming in on the neutral, and you're going to trip the breaker. That is one right there. The second one is going to be if you have the wrong neutral. So when you get in the panel, you're stripping all the circuits back, you're making it up, and you accidentally have, two circuits that are nearby each other, and you grab the wrong neutral. It's happened to me before, master level electrician. It can happen to anybody from apprentice to pro. You just get to rock and rolling, and you accidentally grab the wrong neutral and land it to the breaker. Well, this will allow you oftentimes to turn on the breaker, but the moment that you put a load on the other circuit or the circuit that you're on, it's going to trip instantly. So one of the things that I like to go back and do first is I'll go back and make sure that the breaker was wired correctly. It's very easy if you're not paying attention to land the neutral to the hot and the hot to the neutral. And also the second thing that I'll check is that I don't have the wrong neutral. It is very easy to do. You're in there, you land the wrong neutral, it turns on at the time when you go to test it or the customer goes to put a load on it. Anytime there's a load on it, the neutral is not returning back on the right path. It's not able to monitor, and it's going to trip the breaker. This also can apply to dual function breakers and ground fault breakers as well, but today we're talking about AFCI protection. Also, you want to check that you've not connected it to other neutrals somewhere else in the circuit. So if you pull two hots to a light box, which happens often. I mean, I've been in a switch box with 4 hots in it. And you get in there and you connect those neutrals together from multiple circuits, it'll trip every single time. So that neutral has to stay continuous throughout that circuit only, all the way through the circuit, or the AFCI breaker will trip. And every single time a GFCI breaker will trip. What will happen is you'll turn the circuit on, you'll have current flowing back on a different neutral, or you'll have some of your current flowing back on the other neutral, and your AFCI breaker will trip. Now let's talk about grounds and neutrals touching. Now, I am not positive that this will happen on AFCI breakers, but I'm positive that it will happen on any type of ground fault protection. So I want you to be aware of this one anyways. So if you are in a box and your grounds and neutrals are touching, and let me explain an easy way that this can happen. So if you go and you hook up a receptacle and you go to bury that receptacle back, well, the ground wire is on the same side as the neutral prong. So when you go to bury that thing back, oftentimes that thing will come up and touch. Well, in previous times when we got to use regular breakers and everything was a lot simpler than it was today, you actually would not have to worry about that tripping the breaker. You might be creating some objectional current. You might be doing, causing some other problems down the road, but it's not going to affect the function of the breaker. Well, with AFCI protection, and I know for certain GFCI protection, if those neutrals and grounds are touching outside of the circuit, what will happen is when that ground bends up and touches that neutral prong, if it's GFCI protection or dual function protection, it will actually take some of that current will flow back on the bare ground and not on the neutral, causing the GFCI to think that current is leaking. Now, there is a little bit of current leaking protection on the AFCI, which leads me to think that it may do it. And the reason I don't know for certain is I very rarely install AFCI only breakers. I mainly use dual function breakers pretty much on everything. And the main reason is because I love GFCI protection and I wish that we could get it on the whole home. So I do that every time I install an AFCI breaker. I install a GFCI breaker, which is a dual function breaker, and I put them together and I install one breaker and I get both of those protections for the whole home. And on those breakers, if that neutral and ground are touching, and if you don't know what a GFCI is, it's basically just counting current. So if 1 milliamp goes, or excuse me, 1 amp, it'd be easier to explain. If 1 amp of current comes in, then 1 amp of current needs to go back on the neutral. And if there's any discrepancy of a 4 to 6 milliamp threshold in that count, then the circuit will shut off. So if I had 1 amp coming in and I had 0.8 amps coming back on the neutral, it would shut the circuit off thinking that 0.2 amps was leaking somewhere in the system. So with that being said, if that neutral and ground are touching inside of that receptacle or anywhere in the circuit, what will happen is you will have 1 amp come in on the hot, and you'll have, we'll say 0.8 amps flow back on the neutral and 0.2 amps flow back on that ground that it's touching. Well, the GFCI is going to sense that there's an imbalance and it's going to shut off, thinking it's saving someone's life, but it's actually just being a nuisance. So you have to go back, pull all your faceplate covers off, and make sure you take your flathead screwdriver, shove it in the box, and make sure that you push those neutrals and grounds and separate them. So the third one, and one of the most common ones, and this can lead into the nuisance tripping, is old appliances. So the first thing I do when I troubleshoot AFCIs is I have the customer unplug everything. Unplug everything on that circuit. Often it's an old lamp or an old radio or Meemaw's old refrigerator or, fill in the blank here. And what it is it's just probably, it could be arcing for one. Some of those, could be thinking current's leaking, especially if you're using GFCI protection, especially old refrigerators. And some of them, it's the old motors. When it starts, it gives a, sine wave pattern as if, or compressors, it gives a sine wave pattern as if there is an arc going on, but there's actually not an arc. And what it'll do is think it's an arc and it'll trip. So old appliances is the first place that I start. And the next one is motors, whether you're dealing with a refrigerator motor and compressor, whether you're dealing with an air compressor motor. A vacuum motor is a very, common problem. And some of the new vacuum motors are getting better and better. I just tell people to plug it into another circuit if they have to. If it's a vacuum and they're not willing to replace it. But I'll be honest with you, I just tell customers that they need to replace it. So now let's talk about the way that I troubleshoot AFCIs every single time. Mostly on my jobs, it's dual functions, so there may be a little more due diligence that has to be done here. But basically, if you cover any one of those things first, but if I've covered all of these things and I've not pinned it down to something, let me tell you how I troubleshoot AFCIs with customers. So if they've got something tripping and they don't know why, we've gone through all these steps. I will tell the customer to unplug everything on that circuit. Then we wait a day, okay? If I don't think there's danger. And I can't tell you to do this or not, but I just do it very carefully, and I deal with the customer, hand in hand. I give them my personal number, say, hey, let's work on this together. Let's talk about this. Let's work this through. So I just tell them, if it trips once, we can't pin it down, or if it's tripping at night, tripping in the morning, whatever, I'll just have them unplug everything, and I'll have them wait a day. Wait 2 days, wait 3 days. Okay, if it's nothing, then we instantly know that it was something we plugged in. If they're a little less reluctant to unplug stuff, or if they can't unplug stuff, I'll just have them do one thing at a time and wait a day. Oftentimes, it'll be the actual strip bar that is bad. Some of these old surge protectors are bad, and they're either arcing inside, the little light that's inside there, super low quality light. It's in there arcing and it shuts off the circuit. So with that being said, I'll have them unplug everything. If it's an old strip, I'll just have them replace the strip. And then I have them reintroduce these appliances one at a time. I do this over the phone because I cannot afford to go out to this house every time this breaker trips. We do it over the phone, and I explain to the customer, I'll say, listen, I can't come out there every time that, that this is going to happen. So what we're going to do is we're going to work on this over the phone, and we're going to work on it together because we don't know what it is. And oftentimes it's been a phone charger. It's been a light. It has been a piece of equipment. It's been a vacuum. Sometimes you can tie it to an event. Hey, every time I flick the switch on in this bedroom, the breaker trips. Okay, well, go turn the fan off and then turn that light on. Is it the fan motor? Is it something inside of the wiring? Thankfully, with modern wiring, the way we do it, how we put the power in the light box and then run the switch leg up to the light, if it's tripping when they flick on the switch, check the switch, make sure the neutral and ground isn't touching, make sure the hot and ground isn't touching when they flick the switch on, and then go up to the light. It's a very simple short circuit. Now, it could be a staple in the wall. It could be somebody shot a screw in the wall. It could be a lot of different things, but the first place that I start is I have them start unplugging pieces of equipment. I will tell you that 90% of the time, it's a piece of equipment that the customer's got plugged into it. Then from there, if I've worked with them for a week or two and we still cannot pin it down, and I've also went through everything else that we've listed first, those are the first thing. Assume it's your fault, and this goes for any troubleshooting that you're going back on your own work. I have very few callbacks, less than one every few years. Okay, and if I do, it's usually something like this where it's a piece of equipment. But I mean, that's not to say that I don't hook up stuff and have to troubleshoot it right then on my own. But I'm talking about callbacks, true callbacks where I've left, the customer's paid me, and then I have to come back and fix something. We don't even do it yearly, okay? We rarely go back and do callbacks. We really try to be diligent on site. And if you are doing callbacks all the time, you need to slow down. You need to, dial in what you're doing, and you need to pay attention. You cannot afford to run around doing callbacks all the time. Your employee cannot afford to run around and have you doing callbacks. Callbacks should almost not exist in your business, especially in this industry. It's very finite. Now, there are pieces of equipment that fail. I'm not talking about that. I'm talking about your work needing to be needing to be checked on later and going back and correcting things after you've left. Correct them while you're there. You don't have the money to be running around, $5 a gallon of gas. You don't have the money to be running around and doing callbacks all the time. So if I've went through, I've had them unplug everything, I've worked with them for a while, I've also went through all the steps that we've talked about already. The next thing that I will do is I will start looking in the twilight zone. And I will pull out every single receptacle and every single switch on that circuit. Sometimes, and I train you guys on this channel to never take your razor blade to the very back of the box. When you're stripping your Romex or your cable, strip a 1-inch tip and peel the wire back. The Romex strips very easily because what happens is you get back there and people cut in with a knife and they're cutting all around it and cutting, and when they pull that jacket off, they've nicked it, and they are either touching the neutral and the ground or the hot and the neutral, or they're touching something else inside of that box. So oftentimes I will go through and pull out every single switch and receptacle on that circuit and just pull them out. Sometimes the act of pulling them out separates that neutral ground connection or that hot neutral or hot ground connection, and it's dead shorting. I cannot tell you how many times I've pulled out a receptacle and it's gotten rid of a dead short or it's gotten rid of an arc fault trip. So you pull that thing out And what it does is and oftentimes I'll go in there with a flathead, and this is with the circuit off, of course. I'll go in there with a flathead and I will separate the wires back there. Because oftentimes that nick is way in the back where the Romex meets right there, where all the wires meet. And I'll take my screwdriver and I'll slide them out. And I cannot tell you how many times that will get rid of the dead short or get rid of the arc fault. This can often happen even on really old circuits. So you'll be in a house, the receptacle's been there for 30 years, and all of a sudden it'll start shorting. Well, what happened is when that installer installed it, they slid it with a razor blade, and that thing is finally opened up and it's dead shorting. If you guys have any experience, you've been in a panel where you've seen a wire slid open or in a box slid open, it's kind of scary, when you're working in a panel and you look over there and there's a big number 6 gauge wire because the HVAC guy took and slit all the way down the jacket instead of taking the time and peeling it back. So just something you want to watch out for. So if I pulled everything out, I've separated all the wires, and I'm still having the tripping, then I start really, looking in the twilight zone. At that point, I will stop and replace the breaker. I typically wait to replace the breaker till the very end. I'm telling you, with the new modern breakers and the higher quality that they've got and the thresholds that they're meeting, it is almost always your fault or a piece of equipment from the customer. And I say your fault. You're a big boy, big girl. You can handle it. It's your fault. Okay? Either the neutral and ground's touching, you got it miswired, you've got something going on. If an AFCI breaker is tripping on my job, the last thing I think it is the breaker. The last thing. I go back and look at all my work. It's almost always, like 99% of the time, it's something you've done. Now, you can hear old electricians. Someone will say, no, they still all nuisance trip. I'm telling you they don't. I've installed thousands and thousands and thousands and thousands of these breakers with both technologies, which makes troubleshooting and nuisance tripping even more prevalent. I'm telling you, it's almost never the breaker. So, you may not like to hear that. It's okay. I still love you. We can still work together. We can peacefully disagree. I promise you, I've installed thousands of these breakers. Now, there are some brands that I've used to match a panel that are more prone to nuisance tripping, and I think they're poor quality breakers. So, but that's one specific brand. I'm not going to name it. You might deal with it all the time. If you deal with it, you can drop it down in the comments below. But with that being said, I rarely replace the breaker. Like 1 out of 1,000 times that I'm troubleshooting these things do I replace a breaker. And I've installed tons and tons of these breakers. As soon as I found out about dual function technology, I started installing them on everything. So with that being said, and there's sometimes that you have to put AFCI and localized GFCI protection depending on your scenario. It is what it is. But with that being said, if I've done that, I go back and replace the breaker. If I replace the breaker and that thing is still tripping, it's likely going to be a staple or a nail. I'm sorry. And you might have to rewire a portion of the circuit. And at that point, you can start disconnecting a run at a time until you find it. And I hate to say that. And you can go back and try to rehook the devices up after you find it. Sometimes it could be a device inside the device. I suppose before I started rewiring anything, I would replace a device, even if they're brand new. Often we don't have to do that, but I suppose I've never had to rewire anything yet. I haven't had any staples or anything like that, but it's out there, especially if you've got a lot of guys working for you. They're banging on staples as hard as they can bang them on. It very well could be a staple, or somebody shot a nail through it, or a screw through it, or there's some type of really bad bind. I've also had a situation where I feel like the wire was bad inside the jacket. I really feel like one time we were on a job, I don't remember if it was AFCI protection or what, but I feel like the wire was broken inside the jacket and was causing the problem, whatever we had to deal with. It's been a long time. But with that being said, these are lots of different ways that you can approach AFCI protection. If you have to replace that one part of the circuit at a time, just try to go to the farthest point where in the circuit, and then you will just dial back and disconnect it one at a time until you get hopefully a short run that you have to replace, and then you can just rewire that little bit of section there. But with that being said, there is no super easy way to do this, but if you go through these steps, it will save you a lot of time, and it will help you in the long run. I am the electrical code coach, and I truly just want to see you win. I want to see you win on every level, personally, spiritually, financially. I want to see you win in the electrical industry. I will literally do anything that I can to help you get to the next level and go higher and higher and higher. You can always email me at electricalcodecoach@gmail.com. I want to give a shout out to our sponsor, Fresh Coffee Please, before we get off today. If you go to freshcoffeeplease.com, you will get the best coffee shipped directly to your door. You can do the subscription service or you can order it by the pound. I'm super grateful for freshcoffeeplease.com. Please let us know in the comments if you've tried it, if you're liking the coffee, and I can't wait to see you on the next video. Remember, the only way that you lose is if you quit. Let's get to it. This video is brought to you by freshcoffeeplease.com, shipping fresh roasted coffee directly to your door. If you've never had fresh roasted coffee, then you truly haven't lived. And they've got it set up super simple. You can buy it by the pound, or you can do one of their subscription services and they'll send it to your home every month. You just select how many pounds you'd like. You select whether or not you want it whole, bean, or ground, and then you just go to cart. And during this time, if you will use the coupon code CODECOACH, you can get 10% off of your first order. I'll put a link down in the description below. Let's get to it.